Hi everyone, hope you are fine. I'm Omale Fidodo, your celebrity mathematician. Today we are looking at logarithms, and it has relationship with the topic we just finished, indices. Now, what is logarithm? Then let us show the relationship. Logarithms of a number a to a given base b, denoted as log a to base b, is defined as the index or power or exponent to which this b must be raised to obtain a. Let's look at it. What we just said, let's check it in mathematics form. That means a is equal to b raised to the power of x. This is the index form. I will say that index is the same thing as power or exponent. Now, this is the English. This is the index form. Then the logarithm is a to base b equal to x. This is now the log form. Both of them are correct. Now, can you see here? We said this is the b, this is the x that the b must be raised to obtain a. Then, having said this, let us write one indicial equation and check how we can solve it using logarithm, how we can represent them. Look at it here. For example, 2 raised to the power of x equal to 4. How do I represent this? From here, look at it here. This shows that the log 4 base 2 is equal to x, which still implies that log 2 raised to the power of 2 base 2 equal to x. And in this form, this can still be 2 log 2 to base 2 equal to x. Now, in logarithm, there's one special thing. The logarithm of a number to its own base is 1. Now look at it. That means it will be 2, 1 equal to x. Therefore, x is equal to 2. Now, this is indicial equation. I used logarithm to solve it. The logarithm of a number to its own base, that means the same log having the same base, is 1. It's a law of logarithm. Now, if I want to solve this, let's say I want to continue from this indicial equation. And it gave me, given that 2 raised to the power of x is equal to 4. I'll say that 2 raised to the power of x is equal to 2 raised to the power of 2. Now, when in indices, we said that when they're having the same base, we can equate their powers. And when they're having the same power, we can equate the base. Here, they're having the same base, 2 here, 2 here. So I can equate their powers. It's the 11th law I gave when we're solving indices. Go back to our indices video and learn from there. So, therefore, my x is equal to 2 using indices. This is indices form. So you can see it here. So indices and logarithms have a very good relationship. A very good relationship. And that is mathematics for you. If you know A, if B comes up, you can solve it. Mathematics is very good. What you need is analytical skill, and mathematics will give to you. So you have to think critically. But with MATECS, you can get everything. So I've done justice to that, and that will take us to the laws of logarithm. The laws of logarithm. Now let's play with the laws. The laws. Okay, let's look at it here. Number 1. log A times B in base A is equal to log A to base A plus log B to base A. This multiplication law of logarithm. 2 log A over B to base A, the same thing as log A base A minus log B base A. 3 log A raised to the power of x to base A is the same thing as x log A to base A. Now that's what we use here. When I have 2 raised to the power of 2 as log, I have to take the power to the back of the logarithm. You can see it here. So this is a law in logarithm that I applied here. Is that understood? Now from here, if I have 4 log A to base A is equal to 1. I said something here. I said the logarithm of a number to its own base is 1. That is a law of logarithm. That means I have applied 2 laws here. I applied the power law here. I applied the number 4 law here. Good. Then number 5, log A log 1 base A is equal to 0. Remember, in indices, we said that A raised to the power of 0 is 1. And here, from the representation here, A raised to the power of 0, if I want to bring this in an indicial form or equation, it will be A raised to the power of 0 equal to 1. Is that understood? Don't bother. To start giving examples on them, you understand better. Nobody comes to MATECS without getting it real. So number 6. Remember that what if log A raised to the power of 0 is equal to 1? I've said it. Now what if we have log A B, log A to base B? This is the same thing as what? 1 over log B base A. If you are having a logarithm in this form and you are to, maybe the base, you are not comfortable with it and you want to change it in this form, this is how you can change it. 1 over the base here becomes the log and the log here becomes the base. Once you introduce 1 over, take it. Then we have another law. We have another law. If you have log, that's number 7, log AB is equal to log A to base A over log B to base A. Now in this case, I want to solve it and maybe they give me something that I'm not comfortable with. I'll give a base. I can give this A can be 2, 3, 7. I can give any base to myself. Then I'll change their form. So this becomes log A to base A. I will choose the base for myself, and the B I'll choose the base for myself. If I work it, I'll have a very good answer. So these are the laws. If there are any other law that we've not set here, as we go on in this logarithm, we will mention them. Now, see the questions today. I will not go far today because it's an introduction. They say express the following logarithms in index form. Question A. Question A. That is A, Roman numeral 1. Given that log A to base B is equal to A. It implies that the initial form is A is equal to B raised to power of A. That is the representation in index form. Roman numeral, the one that has number, because I've done justice to the one that has alphabet, that is IV. IV, given that log K base B is equal to 2, it implies that the index form K is equal to B raised to power of 2. That is that about that. Question B. That is B part. Part B. Part B. I'll take only the same thing. AS is equal to B. That one we've done it. You know it already. That means this is the log, this is the base, and this is the index. So let me take 27, that is 1. 27 raised to the power of x is equal to 81. It implies that the log, it will now be log 81 base 27 is equal to x. Very simple. So I want the fastest finger to solve this, the remaining ones. The ones we've not done from part A and part B, solve them and get your prize. This is an introduction to logarithm. Solve them and get your prize. They are very simple. You can use just 2 minutes to get them. So the first person to upload it on MATECS group or our YouTube, the first person will get the prize. Thank you so much and remain blessed. Subscribe to our YouTube channel, MATECS 12 at MATECS 12. Thank you.